Okay. So welcome to chapter 6, Introduction to Cloud Computing Trends. We're saying here that cloud computing has become the foundation of a range of important applications, and we shall agree. At the same time, also other technologies are also driving further the advancement of cloud computing. This chapter focuses on the relationship between cloud computing and other related fields, and also introduces you to some of the new technologies related to cloud computing. Upon completion of this chapter, you will be able to describe key technologies that underpin cloud computing. You will also understand the relationships between cloud computing and other fields, and also understand the most prominent cloud computing trends. So fields related to cloud computing. Internet of Things. Who has heard of Internet of Things? Okay, Marvin, you can go ahead and tell us. Your hand is up. Oh, he put it down. Okay, so just you can see, Internet of Things is a concept of connecting everything through the internet, including all sorts of communications and interactions. That is the interactions between people to people, the interactions between people to things, and also the interactions between things and things. Basically, we are living in a world of Internet of Things. Like almost every device today, at least in an ideal situation, is connected to the internet. Your mobile device, your laptop, your wristband, your watch that you're putting on. Some of you people at your homes have fridges which are connected to the internet, your television sets, your sneakers. Some people have sneakers which are connected to the internet, and your door sensors, your sensors, and so many other things that are connected to the internet. So that entire category of having different things and everything connecting and sharing and transmitting data is what we are referring to as the Internet of Things. Seeing some message in the chat. Everything like YouTube reminding you to take a break from viewing. Even things like YouTube reminding you to take a break from viewing. Okay. Internet of Things, devices connecting share data through the internet with less human interaction. That is also true. So basically it is the connectivity of things. And there are a few things that we should take note of, the technologies that are used by Internet of Things. One was the RFID. It's a type of smart card which used to enable Internet of Things. And the term Internet of Things was coined by Aston, the executive director of MIT's Auto ID Center. That was in 1999. Also, we have the sensor technologies. The world is full of sensors today. Even the watches we are putting on these days are full of sensors. So various types of sensors are used to detect and collect environmental signals, including temperature, humidity, pressure, and even our biodata and everything around us. So basically all those sensors are connected and coming up with what we're calling the Internet of Things. You have your home, you have your smart cards, your cars are connected to the internet, your Google Maps, your camera, even your money, you access it through the internet, and so on and so forth. Also, there's a technology of embedded systems, and basically an embedded system is a dedicated computer somewhere in which hardware and software are tightly integrated to offer specific functions. And usually those functions are always part of a larger kind of system. So let us look at another concept here, what we are calling big data. Who has heard of big data? Anyone? Just say mic check.
I think big data. Check, mic check.
Yes, please.
I think big data basically is a large chunk of data that can be used to, like in machine learning, can be used to get a certain aggregate in machine learning. For example, like in our data set, because normally we use it to detect some things in, we use that data to detect whether it's cancer or no cancer, sort of things like that.
Okay.
But still use of that data and we predict the future.
Okay. Thank you so much. Marvin? Yeah, and you're correct. So we are saying that today the world is leveraging on artificial intelligence, right? We're leveraging on artificial intelligence, and it has been held as a technology that has changed our world, or even human beings. Like most of our work today that we're doing, we have maybe someone running your tasks, some app running your tasks for you and reminding you when you're supposed to take your medicine, reminding you when to carry an umbrella, reminding you when to maybe do anything that you feel like you want to do. And AI, we should take note that it is a combination of both cloud computing and big data. And they are driving a digital transformation of the ICT industry for even higher intelligence. So big data, it was originally an application of cloud computing, and it could not work without cloud computing. Big data was placed in the technology trigger, I think, in around 2021. So it also became more of a trending technology on its world. So big data refers to data sets that are too large. Important concepts to note: data sets that are too large or complex to be handled by traditional data processing application software. So such data sets are generated by Internet of Things. So we have already looked at Internet of Things, and we said having so many devices connected, talking to each other, either people to people, our conversations we are having on WhatsApp, or maybe things talking to things, or even maybe people talking to things. And due to the radical increase in the total number of those devices connected to the internet, ever more massive data sets will be generated. So on a daily, just imagine the amount of data that is transmitted over the internet. Imagine how many number of people are having Zoom meetings or Zoom classes to date at this particular moment in the entire world. They're quite a number of people. And all that data is processed and collected somewhere to enable cloud computing and also to help us come up with meaningful information. So some of the characteristics of cloud computing is that the amount of data, the volume of data, like it has a large amount of data. And of course, the speed at which this data is generated, the speed is high, okay? And then also the variety, it has different types of data. Everyone is sending in data, voice notes, images, texts, games, and all that. So it has a variety of different types of data. And of course, the value that can be extracted from that data is very, very important and key in terms of making meaningful decisions. So big data, the way it is processed, our IoT devices connect that data, they transmit it, of course, and that data is stored somewhere through the use of cloud computing technologies, and later on that data is processed, analyzed, and after being analyzed, people can always search that data, they can mine from that data, and then they can make meaningful use of that information. So there are basically these four processes. One, you get your data. After collecting your data, you cleanse it, and then you process it into meaningful information. After processing it to meaningful information, you make use of that data and it makes sense to you as an individual, and then you become knowledgeable because you can relate to that information. You can pick out important things from that information. And people who have acquired the knowledge and can use that knowledge produce what they call intelligence. And most companies to date are paying for this intelligence. That yes, you have the information, but do you drive knowledge from that information? After driving knowledge from that information, can you actually apply that knowledge so that we get a competitive advantage of intelligence? And then the cycle goes on and on and on and on. So let us look at artificial intelligence. We have already been talking about artificial intelligence, and we are saying that artificial intelligence, yes, please. Yes, Ahmed?
Hello, good morning, Mr. Ssendi.
Good
Please,
morning.
I have a question. Yeah.
Mm.
What is the difference between big data, data science, or data analysis? Because I think based on what you just explained now, I think they're almost like similar also. I don't know.
Yes, they are ideally very similar. And as you can note, data science, it is the whole idea of you understanding what data is. It is basically it is an interdisciplinary field that uses scientific methods now to process and also to come up with those algorithms and also the systems to extract that knowledge and insights from the structured and unstructured data. And now all that data which is collected, that structured and unstructured data, is what we are calling big data. So ideally, data science is more like you applying scientific methods to process that data so that you come up with meaningful information. Ahmed, are we okay?
All right. So thank you.
Okay. All right. Okay. So just maybe to just make it clear, data science, it is that term that encompasses all the techniques and tools that you're going to use through all the life cycles of that useful data. Whereas big data, it is basically that term that refers to a large data set. So with big data, we are referring to a large data set. Data science, that's scientific techniques we are going to use to manage, manipulate, and drive meaningful information from this large data set. I hope that makes sense.
Absolutely. Thank you.
You're welcome. Okay, so we're looking briefly at artificial intelligence. And we're saying artificial intelligence is an area of cloud computing science that focuses on research into development theories, methodology, technology, and application systems for stimulating and extending human intelligence with machines. Artificial intelligence, in summary, is the ability for the machines to have our human intelligence, for the ability for the machines to think. So applications of AI include robotics, speech recognition, image recognition, natural language processing, and all that. Many of us go on Google and try to search google.com, and maybe you get relevant things for you, and maybe you try to get the data that is relevant to you. And you're not certain how Google has determined to complete your search, that you wanted to search for that. Yet they use some kind of algorithms that are supported with a back end of big data. They know what you have searched for in the past, or even what your friends are searching for, the friends that you talk to more often. So they derive from that, they derive from those algorithms, and then they give you the results, and you have never noticed. You open your phone to search something, and it completes for you, and you don't even pay attention to how this small, tiny search engine is able to predict what you want to actually search. Your keyboards on your phone, as you're typing some of the statements, how are you? It completes for you, and based on your patterns on how you have been typing. And this is what we are calling artificial intelligence, the ability of the computers to be able to think for you. So some of the elements of big data, so some of the elements of artificial intelligence, we already have big data. And I must say that artificial intelligence, just like my colleague, I think it was Ahmed, he explained, I think it was Ahmed, I don't remember who exactly, he explained to us and told us, and AI entirely depends on big data. It depends on these big data sets for it to be able to make those decisions based on the different scenarios. So it's upon this big data that people are going to come up with algorithm and say, if the color is yellow, then the computer should maybe do ABCD. If the color is blue, then the machine should maybe do ABCD. So one element is big data. Artificial intelligence is intelligence acquired by summarizing big data analytics. Then the other element is algorithms. Algorithms are a very fundamental way by which AI is realized, and an effective method to extract data intelligence. So computing power, of course, for you to be able to process and run the algorithms, you definitely need computing power. And it is a prerequisite for applying artificial intelligence algorithm to extract value from our data assets. And of course, scenarios. Big data depends on a scenario. Our machines, for them to be able to do something, scenario A must happen for result B to be produced. So big data, computing power, and algorithms are input that will create meaningful output only if applied to practical scenarios. Those are some of the elements of big data, of artificial intelligence. Cloud computing, Internet of Things, and big data. We have already said Internet of Things. Here we have all our devices connected, our audio collector, our video collector, air and soil sensors, office equipment, household appliances, production equipment, and all these we are mining and we are getting data from those devices, which data is what those large sets of data is what we are calling big data, which can be either structured, and by structured we mean that data is in a fixed format with limited length. Maybe it is character, or maybe it is the different types of data. For example, information in a table is structured, such as values of nationality, gender, names, last name, etc. Whereas unstructured data is a data with a variable length and not fixed format. We don't know if it's going to be in the format of text, or if it's going to be in the format of date or time. It is not clear, and it has a variable length. It can either be too long or it can be short. For example, we send voice messages to each other every day, and my voice note can be long, it can be short, or maybe a video, or other types like pictures, movies, and on, and etc and etc. Okay, and then semi-structured. This is data with certain structures, formats like HTML, all XML, HTML or XML, and other formats that are kind of like semi-structured. So after all this data, for us to be able to process big data, remember it is relying on the power or ability of cloud computing. We have our data centers somewhere, and these data centers are providing those services which big data is going to drive on. And then you can be able to access the services either using your mobile internet or the traditional IT or internet access. All right, so the 5G era, you all know how the world has evolved, and we all know that cloud computing came into play because there was internet, and it is entirely dependent on the internet. So we also need to pay attention to how the internet is evolving today and how it's going to be evolving in the coming years. For those who are interested, there are also other courses that Huawei is offering in 5G area. You can go ahead and do those courses if you want to find out more what's in the 5th generation of mobile communications technologies and their standards. But basically, what 5G offers us is enhanced mobile broadband. It's going to transform our connectivity into a platform. So we have connectivity as a platform, and reliable, low latency, and of course, massive number of connections that can connect to a particular device at that given time. Okay, so with 5G, everything will go online and stay online by default. That's what they're telling us. And we are just excited and waiting for them to roll it out across the entire world. And then we shall be happy. Of course, we have had so many stories from people how the Antichrist and what and chips and all that. So, yeah. So, but basically the world is evolving, and also as people who are interested in cloud computing, we need to pay maximum attention to how also the internet is evolving. Okay. Someone in the chat is asking that latency means what? Latency is that period of waiting, that delay before a transfer of data begins following maybe an instruction for its transfer. Maybe when you try to send out information and in the background, you know, those packets have to be first sent to establish the connection and then received back. Then they know that the connection is stable and then you are able to transmit. So that delay before you start transmitting is what we are calling latency.
Mic check.
Language. Yes,
Mic check.
please. Yes, please.
Where do we normally apply NLP, natural language processing, AI?
Where do you what?
Where do we apply natural language processing?
Where do we apply natural language processing? Natural language processing has always been a topic of interest because it is a subfield of computer science, basically for trying to train computers to be able to understand the human language, to have interactions like how you'd speak to your computer. And that, of course, you apply it, either you can apply it in data science or also in artificial intelligence. So in how are you going to process, you know, the language that you understand as an individual to the language that the computer is going to understand? That means that you need to collect huge amounts of data. You need to collect huge amounts of data, and maybe the words that follow each other, like how are you, broken down into a syntax that the computer will understand. So whenever it sees that statement, it knows that I respond with I am okay, something like that, something like that, something like that. So it is a branch of artificial intelligence, and basically it just helps to, you know, to train computers our language, to make computers learn our language so that they're able to interpret it and also manipulate it.
Or like Sophia, this human
Yes, yes.
the robot.
Yes, please. So yes, like Goretti, your noise was background. Like Sophia, yes. Or like Siri, or like Google Assistant. For the computer to be able to understand what you're telling it, or like Bixby on Samsung, for the computer or the machine to be able to understand what you're telling it and also to respond appropriately. That is what we are calling natural language processing. And it's also a branch of artificial intelligence. So just like you hear the word containers, we're also looking still more at more trends. Just like you hear the word containers, like you see this illustration of this picture, this is, I think, a dock somewhere where people are putting their containers of maybe valuables and goods put in different containers. So it is a lightweight virtualization technology that uses operating system level virtualization. So several containers, and these ones are isolated user space, can be created on each operating system, each of which is allocated only a subset of the computer's resources. These containers are usually used more by developers. And proceeding to the next stage, Docker. Docker is also a technology that was driven from containers, and we are saying it is an open source application container engine. And it allows developers to package their applications and dependency packages into a portable container and later run them on other Linux machines. The sandbox mechanism is used for containers, eliminating any interface between the containers. Basically, just trying to show us a difference between the architecture of Docker and also the architecture of a virtual machine. That with our virtual machine, we shall need an infrastructure, hypervisor, and then we shall have our guest operating systems installed on the different virtual machines that are created. Whereas with the Docker, we have our infrastructure, our host operating system. After installing Docker on it, then we can have our different containers, each with its bins and libraries, and then applications which are isolated from the other. More differences between the two, between virtual machines and Docker, is that when it comes to a virtual machine, it is big and it consumes quite a lot of resources. And Docker is lightweight. In terms of speed, the virtual machine is slower as compared to Docker, and in terms of integration, also it is hard. But when it comes to Docker, you can use your Docker applications and instances on any operating system which supports Docker. So the integration is easy, and also running the runtime environments, it is easier. So some of the elements of Docker, we have the image, we have container, and we have the respiratory. So with the image, it is a read-only template used to create Docker in containers. Image, it is used to create Docker containers. And Docker provides a simple mechanism to allow users to create images or even update existing ones. Users can download these images created by others and also use them without making any changes. When it comes to the container, Docker uses the containers to run the applications. Okay, it uses the containers to run the application, and the container, like we said before, it is a runtime instance of a Docker image. A container can be started, it can be stopped, and it can also be deleted. Each container is isolated and is an unisolated and secure platform. The respiratory is a set of Docker images. Respiratory keynote set of Docker images, and a registry is hosted service containing a respiratory of images. Each image is having a unique tag, and we're going to look at the illustration here. Basically, this is the architecture of Docker. We have our Docker client, which is daemon, running on our Linux operating system. And then we have our containers, and we have our images, which we said we can use them to create our Docker containers. And we said our respiratory, it is a group of Docker images. Okay, so let us look briefly at Openstack. I'm going through this briefly because I don't want to spend a lot of time on them, but if you want to, you can go ahead and read further about them. But in terms of just a moment. Sorry about that. So OpenStack, it began in 2010 as a joint project of Rack Space Hosting and NASA. OpenStack is a free open source software platform for cloud computing, and OpenStack requires contributions to be released under uh, that license. So OpenStack is a free open source software platform for cloud computing. This is like an operating system that you need to, you know, on open source operating system that you need to what? To roll out cloud computing. All right, so next slide. Things are not getting done. These are some of the components of OpenStack. We have quite a number of them. And let's look at Nova. So with Nova, it looks at the compute resources. Let's look at Nova. It looks at the compute resources. Nova is the OpenStack project that provides a way of provisioning compute instances, allowing users to create virtual machines as needed. So basically, it helps us to manage our physical servers deployed within our virtualization softwares. And also it integrates our underlying resources into a logical resource pool with the resource view. This is what we're calling Nova. So Neutron is basically for networking. It deals or caters for everything that is crucial in as far as networking is concerned. And it also has the infrastructure as service capabilities for all cloud operating systems. So Neutron is an OpenStack project that provides network service, like we have said. So this one provides network service. This one provides compute resources. Let us look at Glance. We should look at Glance, or let us look at Swift. Swift. Let us look at Glance. Let me go in order. Let us look at Glance. So Glance basically, it manages our metadata for the created images, and it is capable of creating, deleting, querying, and uploading and downloading images. So basically, we use our Glance component of our OpenStack to manage our images that are within our cloud computing platform. And Cinder, we look at Cinder, or let us look at what? We look at Cinder. Let us look at Swift, so to get the difference between our object storage and our block storage, which is Cinder. So Swift, it is an object storage, and it is a common data storage device service, in cloud computing. It deals and it works with object storage, and it is deployed in a scenarios where a single file with a large amount of data needs to be stored. That is some of the keynotes you should note. Whereas Cinder, it works with block storage. So if you meet an objective and it is asking you that which of the following components of OpenStack with the block storage, you definitely know it is Cinder. Which one with object storage? Then definitely, if it is object storage, then that is Swift. Okay, that is Swift. That is Swift. That is Swift. That is Swift. So Celimeter, like you hear the word Celimeter, it deals with metering capabilities to know how much resources have been used and for how long they have been used. And Keystone, it basically helps us with authentication of particular accounts, whether they are permitted to use a few given services on our platform. And he deals with measuring to see how the temperature of our different devices on our platform. And Horizon, basically, it gives you the user interface console so that you're able to access and utilize and use our operating system. So the cloud computing trends, I'm perusing through these. We have talked about them, and we are saying cloud giants are strengthening cooperation, leading to a more concentrated market. Most of them are cooperating, like you can easily integrate their services with other services, which is really amazing. And cloud providers are using more of artificial intelligence, we shall all agree, and hybrid cloud and industry cloud are gaining more momentum. That is very correct. So there's an emergence trend towards cloud device integration. This one is true, like you have integrated your laptop with your phone or with your iPad and then your mobile device, even your phone, and so on and so forth. So other emerging technologies, fog computing and fog computing and edge computing. Basically, fog computing is an extension of the concept of cloud computing and was proposed by Cisco. With fog, as you know, clouds are above us, very far from the ground, very far from us, and you know fog is close to the ground. When there's fog, some people like something like mist, it is closer to us and it's closer to the ground. So it was an extension of the concept of cloud computing. It was proposed by Cisco. So in for computing, data and application sets are stored in edge devices, but not the clouds. They're stored in edge devices, but not the clouds. So the term fog was chosen because fog is closer to us as compared to the clouds which are far away from us. Whereas edge computing is one of the future trends of cloud computing, but it is still in a conceptual phase. And according to Wikipedia, edge computing is defined as a distributed computing paradigm that which brings compute and storage resources closer to where they are needed. So with edge computing, it brings compute resources closer to where they are needed. And that's why these two always work hand in hand. And yeah. Thus, providing us with some of these benefits of having more security since the devices are closer to us, and of course having, improving on the latency and also helping us on the problem of network congestion. I've gone through this already. They said it's an extension of cloud computing services to the edge of the network to decrease latency and network congestion. And fog computing uses edge devices to carry out substantial amount of computation, storage, and communication locally instead of all the data being up in the cloud or in the cloud data centers. And we say that edge computing creates an open platform that integrates more capabilities, including network, compute, resource, and applications at the edge of your network and process data which is being generated. Okay, moving forward, edge computing, these are the advantages, showing them to you already. And moving forward with microservices, so I'm just going to go this through briefly. Microservices are software development techniques that structure an application as a collection of loosely coupled fine-grained services. So in a microservice architecture, lightweight communication protocols are used such as HTTP and resource APIs. Okay. So I'm perusing through this. If you have more time, you go ahead and read through them. And serverless computing, let us look at serverless. Serverless computing is a model for building and managing microservice-based architectures. It allows you to manage your application deployment on a per service level rather than a per server level. And we can break it down into function as a service and also backend as a service. Showing us the difference between our traditional way, how things used to be in our cloud computing, that we have everything. We build a framework that runs on a server to respond to multiple events. When it comes to serverless, build or use separate microservice or function to respond to each event. So you don't need to have your integrated data center and you have infrastructure as a service and you have maybe a platform as a service, or maybe you have your back end as a service or function as a service. You just have it on top of here. You just worry about the functions or the microservices available in the cloud. So characteristics of function as a service: no need of operation and maintenance, able to focus on the code, you can quickly boot, short life cycle, infinite elasticity, and of course it is automated. And the benefits of backend as a service: it is faster, high efficiency, optimized for mobile or phones and tablets, secure and elastic infrastructure, full collection of common APIs, and of course reduce resources needed to launch apps. These are some of the benefits. Quiz: which of the following is not an element of artificial intelligence? Which of the following is not an element of artificial intelligence? We have one, we have our big data, we have cognitive analysis, we have computing power, and we have scenario. Someone is saying B, okay.
B.
Someone is saying B, I'll highlight B, sorry. B, 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 B. Marvin said D. Okay, the answer is B because we already looked at all these elements, but artificial intelligence does not have the ability, does not have the cognitive analysis capability. Do we all know what cognitive means? Who can tell us what cognitive means?
Reasoning ability.
Reasoning ability.
Yes.
True. It's that ability to perceive, to perceive and react, process and understand, isn't it? To perceive something. You see, the way human beings are, we have the ability to, to reason. It's not like in this scenario, if it is artificial intelligence, it is based on the scenario basis. If it is A, or B, or C, then you can give them Q, isn't it? But if it finds that some of the algorithm does not include E, it will not think. It will not think and it will not be able to help you. If you had configured it, if it is yellow, make sure you return this. If it is blue, make sure you return this. And it finds purple, it will just tell you unknown results. Or even crash. So it doesn't have the ability to do that. That is our answer. And yeah, it doesn't have the rational thinking ability or the ability to think, ability to reason. Okay. All right.
Mike, check.
Yes, please. Yes, yes. Yes, Brian Olokum. Was it
That
Okum?
question is very, very confusing
How?
because cognitive analysis capability is somewhat available.
Mm.
Yes, because the AI is when it moves, when you add the predictability bit of it, it should be able to. That's some form of cognitive.
But probability predicting.
Very, very confusing.
Predicting lies on probability, isn't it?
Okay.
And it is not purely reasoning or thinking. It's not that rational thinking that, oh, it is now hot, I think I should do A, B, C, D. With AI, yes, much as they put in those predictions, it's able to predict, but there are algorithms behind there based on that big data, based on those scenarios, and also based on the pattern that you have been using for it to be able to learn. That when someone does A, B, C, D, they want ABCD. When someone wants ABCD, they want ABCD. We should do ABCD. So that capability, it is very hard for the computer because it is the capability of the human brain. And it is very hard because the way you're going to look at something, that's why when it comes to us, the human beings, it is not either 1 or 0. You agree? You may look at something and you think of it differently. Let me just draw this here and I ask, what do you guys see? You could just maybe put your answers in the chat. What I've just drawn here. Let me draw it again. What do you see? Rita said small t. Anyone else? Let us answer very fast. Pius is saying plus sign. Someone is saying across. So we all perceive things. We have that rational thinking, and it is all different because they are produced by our neurons in our brains. Yes, and we perceive things in a different way. But if someone had not got our computer or machine and programmed the scenarios or fed it with these big data or with those different scenarios, that it is, if it is a T like that, it is either a small t, or if the T is longer than that, then it is maybe a plus sign, or it could be either plus sign or that the computer will not give you the results you need. Nathan here is saying that it could be a sketch for drawing a stick man. Very interesting. Okay, so the only function of Internet of Things is to collect the data generated by connected objects. True or false? Okay. All right, I see most of you are getting it correct because that is not the only, yes, it's also one of the functions, but you already seen it's not the only function for the Internet of Things. All right, so having done that, we have looked at those different fields and thank you. And quick question now. I have not yet got the lab environments for us to practice. I'll arrange a lab session for us to do some few practicals, but that also is not going to stop us from continuing with our plan. Now let me pose a question to you. When do you think you should do your mock exams?
After Easter.
After Easter. Who is this?
Mike check.
Yes, Isaac.
Let's
Before
do them
Easter.
during Easter.
Before Easter, after Easter will be too hungry.
But you know Easter is starting tomorrow.
After Easter, because
Let us do them on the Easter weekend. Next week we are going to be busy. Next
no.
busy. Going to be busy.
Agreed.
What you do is you put the exam there. So
Let's
if
do
it is Easter, those
tomorrow.
Okay, this is what I'm going to do.
We are committed to
We'll have a course break.
We'll have a course break. Oh. I will have to change to my other connection, but maybe just a moment. Let me put on my
Hey, isn't me, Ahmed?
Okay, can you see my screen?
Yes.
Yes.
So what is going to happen? You have quite a number of them here. Quite a number of them. I'm going to make them available. I don't know if you have done test 2 and test 3, have you?
Yes.
You have?
No,
You
Not
haven't?
yet.
no,
Not yet, Mr. Not yet.
You haven't? Okay. So, okay. So I'm going to make these exam qualifiers, these mock exam qualifiers available for you between now and Tuesday next week. Is that fair enough? So when you get time, kindly do, and you should get time because they are quite long. They're not as short as the tests you are doing. You may find that one has about like, let me see how many questions. You may find like one has about, as it's loading. So kindly find time, not during the Easter. If you can, you can enjoy yourselves. You won't be penalized. But first Easter Monday is also a public holiday. Okay, between now and Wednesday, right? I think that is fair enough. Is it?
Yeah. Yeah,
So
at least.
at least you have, let me see how many days. You have 1, 2, 3, 4, 5. 5 good days. You should be able to do that. Now on Wednesday, we shall do the Huawei mock, and that one has to be done at the same time because it prepares you for the exam, and also because going through that drill is the same drill you go through when you're doing the final exam. Okay, so but by Wednesday I expect that people who are going to qualify to do the Huawei mock exam have done these exam qualifiers. Please kindly take them and treat them with a concept exam, because I am going to be very keen. On the tests have not really been so much, I've not been giving really so much attention on them, but these assignments, they are really important, and please kindly do them. Okay, and I'm going to only and only give you 3 attempts. Only and only. Idea it was even going to be 1 attempt, but I'm going to only and only give you 3 attempts, and I'm getting the highest. I'm getting the highest what? I'm getting the highest. I'm taking the highest attempt, the highest score in all your attempts. So 3 attempts. Kindly make sure that you do them, and by.
Excuse
Mm,
Hello.
yes, I can hear you.
I missed you. I don't know this. Yeah, there's something you're talking about only and only. If you can repeat it from there.
They are saying I'm going to give you only and only 3 attempts. Yeah. Only and only 3 attempts, and the pass mark is at
Okay.
85%. So kindly get time, do it, and take a screenshot of your best score and share it with me on a Telegram, in my inbox on Telegram. Is that okay? So these are the three: qualifier 1, qualifier 2, and qualifier 3. Kindly make sure you do them between these 5 days that you have. Also, from there on, I will be able to generate the list. And after our mock, the Huawei mock exam, it only has 30 questions for it, but it does not really prepare you well for the exam. But I assure you, if you do these mocks and you grasp or maybe understand or do what and pass them, there's no way you'll fail the final exam. That is more like a guarantee. There's no way you will fail the final exam. Just kindly make sure you give it time and you try them out. In my time, a few years ago,
Yes,
I
mate.
was satisfying. What we used to do, we used to discuss them. You can get one colleague, you can create a session, and after sharing the session, they're going to be online. The link, someone is asking for the link. They're going to be on the same portal, like just before the assignments. I'm going to open them. They're hidden now from students. You can't be able to see them, but I'm going to open them today after this call. So, but assignment 2 is not opening. Assignment 2 should open. Have you tried today? I opened it yesterday.
Yeah, it's open.
Okay. All right. So, yeah, kindly do them. Yes, please.
Yeah. Based on what you just said, I think I reached out to you earlier, having a link.
Having what?
And I actually put a message on the
Mm.
a message on the chat on our group
Yes,
on
yes.
Telegram. We should have a discussion, more maybe the response out of over 100 of us, like it's just about 3 or 4 people that actually keen into that idea. So I don't know if at all there is a way whereby we can all set a day, maybe in the weekend or so we can go through all what we've gone through, like since from the beginning to the end. I even spoke to one of our colleagues, which I gave information about all these things, and she agreed that I don't think I think we want to achieve everything that we've covered so far. So I don't know, maybe if we can create a session, if we can all agree on a date, maybe it's an hour or maybe an hour and 30 minutes that is convenient for everyone. We can go through what we've gone through, like maybe, for example, maybe the questions. I think it's going to help us. It's going to help us in a long way.
Okay. My network was kind of bad, but your suggestion is really valid and good. And I think that's a point which I was trying to drive at. So if you can get like a day, you get someone's account. You didn't hear too. I thought it was from my end. Yeah, but you get like someone's account. You go through what you have been, what you have covered from day 1 to now. You go through those questions as a group. You can even discuss them. Trust me, there's no way you will fail to score highly in that exam. So I think it's a valid suggestion. And if you guys are up for it, then why not? So I think that will be all. For today. Having said that, I want to wish you all, I'm going to send the attendance later on Telegram. And having said that, I want to wish you a lovely, happy holiday and enjoy yourselves, have time. But don't forget that you have an exam coming in soon. So as you're enjoying, also get up some time and go through some of those few concepts. All right. So thank you so much, guys. It has been a pleasure and an honor for all the classes we have had this week, and allow me to end the call now. Happy Easter to you all, guys.
Happy Easter too.
Okay, I'm going to just leave the chat in case you guys want to stay and discuss more things. I'm not in the call, but I'm going to just leave the meeting so that you can go ahead and discuss anything if you wish to. So allow me to leave.